Good day to everyone. Today I'm going to show you how to analyze a risk assessment study. And we take leishmaniasis, which is your study, as an example. This applies to all risk assessment studies, whether it's infectious diseases, parasitology, even sometimes non-communicable diseases. So this is an example. Let's just first of all, let's go and see what is case control study. Very quick. So we used here you can use any of these statistical software. You have this APN for free, which I use. You have SPSS, you have Prism 8. I have 5, which is old SAS. Any of these, you can use them. At the end, just we get the statistical analysis correct. That's the main point. First of all, we use odds ratio. We use odds ratio. Odds ratio is for risk assessment. And risk assessment study is a case control study design. So when you are going to write the manuscript, you are going to, to highlight that this is a case control study design, because you have collected data from the past, from cases and controls. It's not a cross-sectional. So this is a case control study design. And the case control study design is usually, we have the disease, people with disease, and people without disease. Example here, cardiac heart diseases, and the same here, no CHDs. And you have the exposure. This applies to all. In your study, this is going to be Leishmania here, no Leishmania here. And the odds ratio is usually, or the case control study, first you select the diseases or the diseased people, and then you select the controls, and then you ask them retrospectively what are the risk factors they have been exposed to. For instance, it can be health education. What's your health education? You ask the same question for both, those with CL and those without CL. Age for both these and those. So the two groups. So the two groups, you assign them first. You assign them first, and then you go and ask them the exposure of the exposure questions. Do you smoke? Do you not smoke? Do you have this? Do you have that? Do you practice, let's say, physical activity? Do you not? And so on. So first you assign, and then you ask for the risk assessment factors retrospectively. And then you have these 2x2 table. From this 2x2 table, you have A, B, C, D. Then you get A times D over C times D. This is the odds ratio. Then odds ratio. If you see here, this times this here over this times this. This is 1.62. That's the odds ratio. What does odds ratio mean here, OR? What does it mean? It means that those who are cases have more probability of 1.6 higher than those who do not have the disease if you are smoking. That's what odds ratio means. So you are comparing disease, no disease, exposure, no exposure together. So you have two groups. That's why if you have one group in such study designs, your study will not be okay, because you need healthy people to compare to. Look, I took this from one of the papers. When is odds ratio low and high and intermediate? I refer to this publication here, Chen et al. 2010. So very small if it's 1.6 or less. 3. Excuse me, I have to make this bigger. Okay, like this. So if it's 3.47, unless it's small, if it's between this, just make this up, less than 6.7, it's medium, above 6, it's very large. This is depending on this publication. Maybe you have others, but this is a rule of thumb. These are good to identify and to know when to consider it large, small. Again, this is odds ratio. You can calculate the significance of odds ratio using one of these. Fisher's exact test, which is the one that is most common and very accurate because you are calculating. And then you can chi-square, but chi-square you should have the observations here in one of these three above 5. If less than 5, then you have to use Fisher's exact test, Mantel-Haenszel test, and McNemar's test. We are going to use this one. So here we have the odds ratio again, the same, 1.6. That's how to calculate it very quick. And this is how to interpret it. Yes, this interpretation, we will come to it at the end. So let me just go here and then choosing this. This is a good one also. That's just before we start. We'll go back to that one at the end. So here we have types of measurements. We have nominal, ordinal, interval, and ratio. And your study as risk assessment is going to be here, nominal, because variables into categories, yes, no, male, female, positive, negative, and so on. And it's a numerical at the end. So nominal and ordinal, these here, qualitative, yes, positive, negative, pregnant, non-pregnant, and so on. And these interval and ratio, they are quantitative, numerical or continuous. You are here. So your study lies here, nominal or categorical. So these, you are number one. Paired group, you are not here. Your risk asset, you are not here. Matched group, this is you. This is your study. Your study, you have two different groups. One of them CL and one of them non-CL, and you are comparing. Better to have, for instance, the ratio from this to this, minimum 1 to 1. 1 to 2, much better. 1 to 3 is perfect. So minimum 1 to 1, which you have. Also, it's good to match it. You know, we call it to make it comparable. So if we have in this group, let's say 50-50 male, female, then here it's going to be this, should be the same. That's matching. If we have, let's say 60% above 40, then this one. So almost the same. The more you usually people match for sex and age, because if you select more than one factor or multiple factors to match, it will take you time to find or to create your groups. This will become difficult. People usually match with sex and age, and depending on your study. If your study is talking about obesity, then weight is going to be included. So this, you are here, matched group. Measurement in two different groups, but matched, yes. I am not going to elaborate very much on this. This is a good one. This you have to know. So where are you here? That's the idea. Okay. So you are not experimental. Your study is not experimental, RCT, randomized and non-randomized. You are observational. This is better, by the way, and more expensive and time consuming. More expensive, better, time consuming. But we go for observational. You are observational. Are you descriptive? No, because you are not describing a case or describing series of cases, group of cases. You're not doing survey. You are analytical. And which one? Case control. So you are observational, analytical, case control study. So in the description, when you write, I am doing observational, analytical, case control study. So which type of statistical analysis do we use for this? Okay. So you are here. You are comparing, these are the depending goal, study design, and variables. You are not here, you are not here, you are somehow here, yes? Unpaired, compare two groups that are unpaired. Unpaired meaning not, for instance, me before and after. This is pairing. Or let's say DR before and after. No, this is a group and the other group is different because this is a group with CL and the other group is people without CL, so they are different. So you are not paired. So you are two groups, you are unpaired groups, and you are which one of them here? Are you continuous and Gaussian? No. Are you ranking? No. Type of data? Yes, binomial, categorical, binomial, positive, negative. So you are here. You are group, two groups, unpaired groups, and the type of data is binomial, categorical, nominal, and then these are the tests that you have to use. We use Fisher's exact test. We use chi-square when we have large amount of data because the Fisher exact test is a calculation and chi-square, Pearson's chi-square is an estimation. Usually they are close to each other, but this one is a calculation and more accurate. We use odds ratio along with this. We use relative risk, and that's also, you are here. You are the second one. Sometimes we can use compared, two compared, paired here, two paired. Paired, then we have to use McNemar's test, and we use this many times. McNemar's test. You have a slide and you want to see, or you have a patient, let's say one patient, and you test the patient for leishmaniasis using two diagnostic tests. So you are using on the same patient, on the same slide, on the same sample, you are testing two methods. This is here we use McNemar's test. Anyhow, forget about this. You are here. Two groups, unpaired, binomial. So we use Fisher's exact test and odds ratio. That's good for you to know what type of test and why. Forget about this. I think this is the thing I want to show you here. Designs. Good. So where are you? Where is your study? Study design. Yes. Dichotomous, unmatched, matched. You can have yes, you can have it matched or unmatched. Both are okay. Then we are single, multiple. We are single type of data. Then unmatched, maybe. I don't know if you matched or not, but we used also this one here. So you are binomial. You are binomial. If you are matching, then it's okay. So you are going to use this one for matching, but you are two different groups, unpaired groups. So you are here. This and this and this. You are mostly here. You didn't do the same group, two different, let's say, procedures on the same group. No, you had two groups. So binomial, fit, which is Fisher's exact test, or chi-square, confidence interval, and odds ratio. So your study lies unmatched, single, and binomial. We didn't go to multiple, so these are other studies. Just to give you examples of it from literature, PubMed. This is a one we did some time ago, paired binomial McNemar's, because this is the slide we used before and after, and two different methods, smear and PCR. This is not this is the one that is interesting to you, and the one that resembles your work is this, unmatched, single, and binomial, Fisher's exact test. And that's what we did. You see, cases, controls, Leishmania and Leishmania, odds ratio, and then the confidence interval. Maybe we did not add a column for the p-value, which we should have done this. Fisher's exact test. You can go to this one also and have a look at it. The same thing we did after, let's say, after 20 years, unmatched, single, binomial, Fisher's exact test. That's where you are. And this is how we did it. This here, we were more experienced, so we added, look, we added the CL, no CL, yes, no, that's the risk factor, odds ratio, confidence interval, so this is the OR, and this is the confidence interval, and then the p-value. We will show you. So these are the ones, or the way that you should look at your data and you should look at your study. So now I think I have given you all the things that you should understand. Okay, now let's go to your data. This is your data. This is your data, cases. You gave me this, yes? Okay, so this is your data. And from 1 to, let's say, 194, yes? You can see 1 to 98. These are the cases. And these are the localities, and this is the district, this and so on. These are the questions. After you ask the questions, you made them somehow like Excel file, which is an Excel file. And these are the controls. Yeah. People who are not CL, non-CL, healthy people. Also the same number, 98, and within the same. So what should we do with this? This is a raw data. First of all, we have to prepare a file for analysis. You have two types, either, or two ways to do it. Either you do it by Excel file, maybe it's faster as students, or you can go to EpiInfo itself, enter data and create form for EpiInfo, and maybe I can show you recent forms. Hepatitis A, for instance, this is hepatitis A. Okay, so you can do like this and just start filling. create a form, a very nice form like this one. That's we did it. And we have 334 patients here. You can do this for people who want to come back and for people who want something professional. Or you can do it just in the way you did, very quick. This goes down. Or you can do it in the way you did, which is Excel file. Excel file, cases and controls. What I did is this. I brought all the cases and controls together, like this. Brought them all together. And I added a very important, very important column here, is CL and not CL. So I just put CL, yes, and the patient who's healthy, no, because this is the one which we call the outcome, because we are going to construct a 2 by 2 table, contingency table, 2 by 2 table. We are going to construct this based on the outcome. Outcome is the disease. So this is very important. Even if you want to make let's say a program like this one, this one, for instance, look what I did, case and the beginning, case and control, because your analysis is all the time going to be based on the comparison between those who have the disease and those who do not. So first thing in any programming, in any building up of statistical analysis regarding the case control studies, you have to assign who are the cases and who are the controls right from the beginning. Otherwise, it's going to be a problem. So the first thing I did is this one. I added this one. And then I told you that we have to clean data or clear data, because data cleaning is so you see here, they are all together. So data cleaning is really important, because if you don't clean your data, you do not filter it, as they say, garbage in, garbage out, good in, good out. So you give it good data, you get good results. So that's why I told you, please classify this as city, village, camp, and Bedouin, because we have the type of locality. I told you also here we have a group, ages, by age. I told you, please make age groups 0 to 14, 15 to 24, and so on. I wanted age groups much better, because in age groups you can have clusters of people, and then you can get good analysis. Also, I told you about classifying occupation based on ILO, International Labor Organization. Also the same here. See, health education, for instance, education. I told you, please make the education 0, no education. Those who started from 1 to 12, secondary school, make it 1, and those who started above secondary school, university, and above 2. So we have 3 categories. Instead of having them 16, 14 years at school, 16, if you have them like this, numbers, then you are going to go nowhere. It's going to be a problem for you. So all the time make categories, 1, 2, 3 maximum. Maybe age group, like I see here, 4, 5. Categorizing them will make each category composed of many members. And then you can make analysis. So we did all of these, classify. I asked you to do this, and you did all of these in a good way. Modify month only, for instance. I needed when was the leishmaniasis, when were you infected with leishmaniasis? I needed the months. I don't want days or dates. Dates, it will disperse your data. If you put your data in 100 columns or in 100 groups, this is a problem. Just make them in 1 group or 2 groups, 3 groups, so we can make good comparison. So I asked you to do all of these. Okay, so all of these I asked you to do, which you really did. And also, not only that, also education. We had to remove them. You had, for instance, look, education here. Where is it, for instance? Because I could see that sometimes you added something. Yeah, it's not here. So maybe I can show it later on. And then after that, we got the analysis for the file for analysis. See here. If you look here, this is the month. If you look here, where is it here? No, because we removed many of the data. Okay, so if you look here, this is the data after filtering. You gave me everything and I filtered it. And not only that, I went down Look, I went down and down and down and down. Yes. And I removed everything from beneath. See, it's almost clean down here. Because if you don't clean it and you analyze using the Excel file, these garbage data, you know, the notes you are putting here, they will be included in the analysis. So remove them and make them clean also. Uh, District, rural, urban, sometimes I used to see, I don't know where it go, but I said I wanted to tell you about, no, it's not here. Sometimes I used to see here 0101, but it looks like I have removed them, because if you add 01 here, or you add here yes, no, some of you added the question yes, no. Yes, no will be included here. If in the first row, which gives you definition, you add yes, no, or numbers, they will be included in the analysis. So try to make them something that doesn't look like what's in the cells that need to be analyzed. That's very important. So at the end, we made this Excel window ready for analysis. You see, ready for analysis. Sometimes you see something like this, some questions you feel that you don't need them, or you just wasted your time. This comes with experience, because some questions you ask them and you don't use them. I mean, when you want to design a questionnaire, very important is to have the statistical analyst helping you, because he or she is going to be the one who is going to analyze. So he will tell you, put this, put that, this question cannot be analyzed, and so on. So this is the file we have used. This is the one you sent me. No, you sent me these here. We put them together, and then we try to filter them and make some modification, and then we got the one that is ready for analysis, which is this one. Then we took it to analysis. Either you can go just like this, and we don't need this. No. The years, because it's not a very long, we can add them. There is nothing about not adding them, but we have only 2-3 years, which do not mean a lot to us.
Oh,
You only took 1 or 2 or 3 years, so it's not going to make that big difference actually.
okay.
So let's go to this here. Yes. Now look, for the analysis, we have for the APN4, you can download it, it's free from the CDC. You can have classic or visual. You can have both. So this is APN47 dashboard. We need to go to the Excel file, this one, and especially for the analysis file. As I told you, you can analyze here using the file which I showed you a minute ago, the colored one, or you can go directly to the Excel file. So here we can go to, these are the types of files that this software analyzes. So it can be this file, it can be MDB, the old PN4 files, MDB, I have some of them. And also we can go to this one. We want to go to this one because our data is in the Excel, new Excel file. So just put this and go here and browse. And maybe I have to go to, just a moment here. That's you. And this is the file. These are your files, but this is the one that we should work with. This one now, and then okay. Good. So you have all of these, the analysis file. See, this one, these here are the windows here. See, these are the windows. But this is the one we are going to use, analysis file. So we go analysis file and say okay. Okay, so you look here. So you can see we have 192 records and risk assessment 2023 analysis final. So this is now the software can pick everything only from this window, not this, but this window. So let's have a look here. Right click, and then we go to the here. You can go, you can enlist them, you can list all the 192 patients with all parameters in an Excel file. You can do this. You can do frequency. Let's have a look. So we have here, let's say, let's go for instance, the sex, and then say, okay, this is how it looks. You see, this is how it looks. We have 99 females, We have 93 males in both groups. You can have percentage 192. That's one. Also, you can put this here, or you can just minimize it or make it big as you like, and then right click again, make another analysis, frequency, and then let's go for district, for instance. District. Look, Al-Khalil, Al-Quds, Bethlehem, Jenin, Jericho, Nablus, and so on. Yatta. This should have been in the data entry here in the district. This should have been included to Al-Khalil because it's part of Al-Khalil. You can do it here and make or reanalyze, or you can just go back and just put this with this addition. At the end, you have 192, and you can tell Tobas we have 40, Ramallah we have 10, Jenin we have 4, Jericho 34, and so on, and this is the percentage. Okay, that's frequency, which we use. And I have done many frequencies for you. Let's have a look at the results. Look, I did frequencies for you. Look, frequency, CL, groups. You can do the same with the groups, the same. Age, this is in CL, non-CL. The case, the control. Diseased, non-diseased. So it's going to be the same for every analysis. District, in those with CL, Leishmaniasis, those without Leishmaniasis. 96, 96, 96, 96. I mean, your filling of the data was perfect. Yeah, it's very nice. Because sometimes we have missing. In a lot of studies, we have missing. The 6, you see 96, 96. We have male, female, and male, female. Maybe this I added. Rural, urban, village, and city. See, camp, village, and so on. So this is in both. I did all of these for you. See, you can describe them. Okay, month of diagnosis. This is January, February, March, April, May, until December. Of course, we don't have here because they are healthy people. In January, we have 9. In May, we have 16. But honestly, these here do not reflect the mood of the infection itself, because these are selected cases. Our study, which was a survey for all leishmaniasis in the last 10 years, might give more clearer and more faithful results than this one. This is risk assessment mainly. So we selected them, and these are the months again, and so on. So I did some frequencies for you. If you think that you need more frequencies, just ask me. Or sometimes during the writing, you feel that you need something which you did not analyze. You can go back and make analysis, and you find it's very fruitful, very useful, you include it. And if you find it not useful because of missing data or doesn't give any sense, then forget about it. Okay, then this is the first one. Sometimes we do this. This is the one that is dashboard. There is the classical one which EPInfo used at the beginning of its use. So we go like this and make the classical one, which was from the 90s. Just click on it. Sometimes I use this. Go here, just click. Oh, excuse me, what did I do? Okay, so go to Excel file, this one, go here, browse, just do the same, and then we go for I said this one. So we go for the final, and then we go OK, and then analysis files, and then put OK. If you look here, see 192, deleted records, none, and this is your file. You can do just like this, let's say frequencies, and do just this is quicker maybe or more friendly to you. Look, it gives you an example. Frequency, see frequency, L, CL cases, L, positive, negative, and total. You can just say like this. Go for age groups, just another one. Stratify by CL. You know, CL is very important in your study. Which one is CL, which was not, which one with disease, which one without a disease. So here we just say CL and then give us OK. Look what it gave us. Just put this down here. Look, those with CL, yes, above 60, 5 people, and so on, 96. That's those with CL. Those without CL, see, 4 and 50 and so on. So this gives you, you can use this classical way. This is the classical. Just let me have a look at it here now. Yes, here. This is the classical and the visual dashboard. Whichever you want, you can go and have a look at. That's what I did for you, the frequencies. These are the ones. So if you need any frequencies during your write-up, just tell me. Then we go to the most important thing also, to the tables, to odds ratio and confidence interval and p-value for each risk factor. Let's have a look. Now we need to do tables. Let's go for this. Let's go first for the, I will do both, visual, dashboard, the tables, cloud, this one, tables here. And then you go expose outcome. What is outcome? CL, non-CL. All the time, this should be the same. If you are working on CL, you are working cardiovascular disease, CVDs, you are working on leishmaniasis, you are working on malaria, it's almost the same. So you just go and do CL here. That's the outcome, the disease, no disease. And then go to the exposure. Let's say the first one we did was 6. Then go like this and see. Good. So we got this. CL, no CL. CL, yes, no. This is disease, no diseased. And this is the risk factor, male, female. Does it affect males more than females or the other way around? So look here. CL and females, 47. No CL and male, 44, and so on. So you get 4. This is contingency table, 2 by 2 table. And here we have a lot here. So odds ratio, this is very important. Odds ratio, estimated lower upper. So we got the odds ratio is this one here, 0.8. 0.8, which is not very high. And then we go to Fisher's exact test, this one here. Two-tailed, yeah, from the two sides. You know, the Gaussian, the bell shape, the Gaussian on the 2 sides. So 0.56, it's very high. 0.56 should be 0.05, less than 0.05. So these here, we look at this one, and we look at the odds ratio. Fisher's odds ratio and Fisher's exact test. You have others, of course. Mantel, Hensel, corrected Yeats, uncorrected. You have the mid-P exact. Some people, the mid-P, p-value. Also, you can go to the net and read about this. But in your level, go for odds ratio and take this one and take the lower and upper, which is confidence interval, and take Fisher exact test 0.5636. So I did this for you, and I can show it to you here. Look. See, these are examples. This is yes, no, painted interior walls, rock hyrax, CL, no CL, yes, no. And look what I highlighted. I highlighted this because these are the ones you need. And this is the one you need also. These are others. Some people like to use mid-P value, Mantel Hensel, but go for this. You need these 3 numbers and this number, two-tailed Fisher's exact test. Also, you can use, let's say we use here, you can use the prism if you like. Let's give you an example on this. These here, let's say we have this. This one. And then we go for prism. Prism, we are talking about contingency table. Our data risk assessment is contingency table, 2 by 2 table. So just say create, and then you go here and add CL to make it easier for you, non-CL. Let's say here, what do we have here? Male or female? Female on top. So female and male, just make this female, just to make it easier for you. Fill everything, and male here. And then let's go and have a look at this, 47, 49. This goes 47, 49. And this again, 52, 44. 52, 44. And now you have it, 2 by 2 table, contingency table. You have the outcome, CL, no CL, and you have the risk factor, female and male. And then analyze. Chi-square Fisher exact test. See, contingency table analyses. Chi-square or Fisher. Say, okay, we need odds ratio, we need to see it. Specificity, we don't need. Relative risk, we don't need. See, Fisher's exact test, yields continuity corrected, chi-square, we don't need this. Chi-square, this is better. This is exact calculation. Then go and click OK. See, Fisher's exact test, p-value 0.5. If you look at this, excuse me, I can just go and click like that and just make a big, this one here, and just go to the prism and show it here. If you look here, just put this aside. Yes, 0.5636, 0.5636. So it's almost the same. It's exactly the same. Significance, no significance. See, odds ratio, and these are the tables. These are the tables which you already did. So if you look at this, this is the output of the analysis. Which numbers I need? I need this p-value. I need odds ratio, which is this 0.8116. I need the confidence interval 0.46 to 1.4, which is 0.4504. Here it's 0.46. It's a little bit of a difference. It can tolerate it. Don't worry. 1.43, 1.431, and so these are the two numbers. This is now this number I need. This number I need. This confidence interval I need, and we put them in a table. We put them in a table. So you can use Prism, you can use IPInfo, and you can use also tables here. This is the classical way of doing things. Let's make classical analysis table. Look here, L water. In our case, L means CL and no CL. Here, water, drinking water, not drinking water, male, female, painting house, not painting house, age group, and so on. So you can have it. But first of all, outcome all the time, CL, all the time. Then you have the exposure. Let's say we have rock hyrax or rock hyrax, yes, no. And then that's how we do it. Yes, no. I've done this for you, and if you look here, you can have the parameters, risk, relative risk, risks, the odds ratio. We need this. We need this. Confidence interval. We need this. Just go for odds ratio. Fisher exact test. We need this. Not all of what you are seeing, because these are many tests. I mean, you can go to them and read about them. You see, mid-P test, Fisher exact test, T Taylor series, another test. But these are the ones you need. And I have done this to you, I mean, for almost all of them. Look, I have done it for sex. I have done it for Fisher, for education of father. And you see here, it's significant. You see, it's significant. I have done this also for education of mother. I have done this for also, has your residential area been spraying pesticide? Yes, no. And I did this by using this here Prism, this by the usual IPInfo, which is the classical way. And I have done almost everything. Almost. So if you need anything during your write-up, you just tell me. Foxes and jackals. See here, it's significant. City, center, and periphery, inside the city and outside the city. I have done it 2 times, you see. I've done it using the Prism and using also the dashboard here. IPInfo dashboard. This one, IPInfo classical. It's the same. It's just, you can use SPSS if you like. It's just getting the numbers you need. That's the idea. So I think I have done all of these questions for you. If you just go here, and these are the questions. Some of them I thought they are not important, or some of them I might have forgotten. So during the write-up, you can just contact me again and tell me that this was missed. For instance, the occupation, you did not do the sex, maybe, or the rural urban. I've done most of them. What I think, because some of them you can see here, maybe they have no value. Some of them, the nodule, the multiple, you see, most of them are missing, so we don't need. Method of diagnosis, I don't know what does it mean. It doesn't mean a lot for risk assessment. Method, the lab tested the CL patient with PCR, or the lab tested it with, let's say, microscopy smear, or with serology. What effect does it have on the infection itself? Nothing. So I thought this is not important. Site of infection, maybe I don't know if I forgot this or not. Anything that has been forgotten, you can just get back to me and tell me that we need these 3 or 4 variables. You have missed them in the analysis. Please repeat the analysis and do it for us. I can do it. And this is all for what I have done for you. I hope that this is helpful for you. If you have any questions, I can answer. And if not, we'll keep in touch. Do you have any questions?
يعطيك ألف عافية دكتور، يعني it was very beneficial مش بس شوي. وممكن هالكيت إذا في حدا عنده أي أسئلة نسأل. حابة أسأل دكتور أنا سؤال. عشان حكيت إنه الأودز ريشيو إحنا يعني في الريسك أسسمنت ستادي أو في الكيس كنترول ستاديز. طب بس حابة أسأل، لو مثلا إن هيك دراسة عملنا يعني ريتروسبكتيف، نعطي مثال، لو مثلا رحنا على الإمرجنسي روم ورجعنا على السيستم، شفنا مثلا شو الكومبلينتس، أكثر الكومبلينتس اللي بيجوا فيهم الناس على الإمرجنسي روم. هل لو مثلا بزبط أحكي إني بدي أشوف مثلا الأودز لأنه إنها تكون ميل وتيجي في أشياء أكثر ريليتد للتروما مثلا، إشي زي هيك؟
Ragad,
مم.
and all of you, if you want case control study,
مهم.
you can go to the videos here, and you see here case control study. This is my YouTube, and here I have 5 minutes. If I want to explain how to make case control study, very important is at the beginning to decide who is your case and who is your control. What are you
مم.
studying in the emergency room? Are you studying CVDs? Are you studying cerebral palsy? Are you studying that disease? You cannot say the patient is complaining. I need which patient? Does the
مم.
patient have the disease? What disease? What is your interest? Which disease you are going to study? That's first. Second, you have 50 people who have the disease. You need another 50 people who do not have the disease. They are normal. They can be in the hospital. They can be, but suffering from other disease. It can be. I mean, this has been used, but good to have healthy people. So all the time for the case control, you need to define your case and you need to define your control and select 50 here or 100 here or 200 here and the same number, if not times 2 in the control. And then you have to ask Ragad the questions retrospectively. Do you smoke? Do you eat fats? Do you do exercise? And so on. This is case control. By the way, did I answer you, Ragad?
Yes.
Odds ratio is mainly for case control. Odds.
أها.
When you say odds ratio, it's case control. Why? Because we are talking about odds. What does it mean, odds? For instance, you have the lung cancer, that's a disease. You have the smokers, that's the risk factor. So let's say odds ratio is 5. What is odds ratio 5? What does it mean here? It means that the people who are smoking will get lung cancer 5 times more than those who are not smoking. The probability, again,
مم.
the probability of people getting lung cancer from smoking is 5 times more than those who do not smoke. This is what odds ratio mean. All the time, odds ratio, you have to compare between those who have the disease, those who are sick, and those who are normal. Because sometimes both of them, they have the same ratio, so it's less than 1. So it doesn't mean anything. If you are going to do something, let's say to describe any disease inside an emergency room for cardiovascular, and you are seeing, let's say, 50 people, then this is what we call case series. We have a case series, the study on Echinococcus. I did it, me and the group, including Dr. Suhair. And this is what we call the case series. If you are going to describe only one, let's say, very strange and very peculiar case, this is case report. So we don't do an odds ratio here. If you are going to do cohort study, but this is prospective and let's say time consuming, then you use odds ratio maybe. So each design has its own statistical tools. For odds ratio, for case control, it's odds ratio, Fisher exact test, confidence interval. Maybe one thing before I forget, I have to tell you, it's very important if you go to this video, really important. Why? Look, if you want the, is there association? How to report case control? So in your study, you have to go and make a table like this one, where you have cases, controls, odds ratio, and you have confidence interval. Plus, in the paper, we didn't have this. I added this on the video. You have to have the p-value. That's why we need p-value, odds ratio, and confidence interval. Look, these three you have to look at in order to interpret. Look at this. This is an odds ratio of 1, let's say 1 or 1.06. Confidence interval from 0 to 42. Can you imagine 0 to 42? By the way, odds ratio is, I can just give you the odds ratio, this one. So here, no association if it's 1, more than 1 positive association, and less than 1 negative association, protection, less than 1. This one here, you have to look at these three. Every table, in any literature, in any paper, you have to look at these three: p-value, confidence interval, and odds ratio. Look at this one. This is funny. Why? Wide range from 0 to 42. That's very wide range. This means that the level of precision is very low. It shouldn't be very wide. That's one. Not measurable yet, not measure of statistical significance. This one, the confidence interval. But proxy, I mean, it doesn't mean anything. But if you look at it as a statistician or as a scientist, and you see that the range is very wide, like this one, your study is not precise in terms of this male-female risk factor. It's not precise because the range is very wide. Also, CI cross over. That's very important. We said that it's 1, 1, below 1 and above 1. If this one has been crossed, if you imagine this line here, and there is 1 in the middle here, 1. Where is 0? It's here. And where is 42? It's on the other side here. So between the 0 and the 42, there is 1 in the middle here. Not in the middle, but let's say close to the 0. The crossing of 1 is not something good. It's not something good. Look at this one. 1, 5 to 10. They are all positive. 1, 5 above 1 and 10 above 1. And even the range is not very, very far. But the problem is that the p-value is above 0.05. This is not good. This one also is not good. But have a look at this one. The last one here. This one here. Look at this. 0.03 above, and 0.9. Both of them are less than 1. They did not cross. So you should be either on either side of the 1. Good study or good value, the one that gives you either above 1 or below 1. If it gives you something that crosses the 1, then this is not good. So here, CI, which is this one, is very narrow, 0.03 to 0.9, not 1, still not 1. Yet association is very small according to Chen. So why? Because the confidence interval is 0.17 or something. So the association is really low, according to Chen, which I showed you a minute ago. And p-value is significant, yes. So you have to look at 3 things for any paper in your study. Look at the odds ratio, the bigger the better, that's 1. Or the smaller, it can be protective, like if you are spraying against leishmaniasis, or if you have, let's say, on the window screens, protective risk factor. It's not a risk factor, it's a protective factor, which means that the odds ratio is going to be below 1, very low. But you look at this, you look at the confidence interval, and you look at the p-value. All of these p-values are above 0.05, which is not significant, but this is the one that is significant, but not very much. significant, but not very much. This is very important to look at because it tells you how to interpret the results. So go and have a look at it, and it's going to help you a lot during in your discussion. What else did I choose? Did I tell you about? This is the one. Okay, I am done. If you have any questions, I can answer. Okay, cool.
Yeah.
Guys, ladies and gentlemen, see you in the next opportunity and have a nice evening.